Okay, but if I put it in full screen, do you see that?
Are you recording already?
Because they told me to start beforehand, because it would take a few minutes but they will edit it. No worries.
Oh, yes.
Yeah, now it's a black screen, Kim.
Just, it's black, Kim.
That's not very
Unless you have a black cover.
Not really.
Mannheim at night.
Yes. Okay, let me try again. Shouldn't be that hard normally.
I had some trouble when I tried to do this.
Yeah, me too.
So, is it still black?
No.
You can see it.
Fine.
No, it's fine.
And you can also see the next page?
Mm-hmm.
Very small fonts.
All right. Good, then let's see how I'm getting out of here again. All right. Anybody else wants to try?
Janika?
I can try it.
How do we pronounce your name?
Janika.
Janika, so it's fine.
That's right. I don't know if it's shared now.
But I think you can, if you click on the arrow at the top of the screen, you can just remove the small slides and just have the big one.
Oh. Oh, like this?
It's the same.
It's quite small, you know.
Yeah.
I did it via the content library because they said you need to upload it there, but maybe that's...
Yes, I did the same just in case, but it's really small to read. If you want to share your screen, you can actually do it by clicking in the small screen with the arrow at your left-hand side in the black column.
Okay. Yeah, then I need to open it on my laptop first.
Yeah.
I can try now. We have tried before, but while Janika opens, I can try mine. Is that okay?
Okay. Go ahead.
Can you guys see my screen already?
Yes.
Yes.
And like this, it's okay?
Okay.
Okay. How do I stop sharing? How do I stop sharing? Do you guys know?
Click on the small screen with the arrow at the left-hand side. Yep. The screen share.
Okay, the same. It's the same place. Okay. Yes.
I can try it.
Janika?
That's fine.
Okay, that's better. Okay.
I'm again struggling with that. I was trying to share it, but it doesn't seem to collaborate now. Don't know how I was able to do it a while ago. But you don't see my screen now, no?
No.
Somehow disappears this. Don't know what was different a while ago. Okay, now it goes. Maybe it's okay, I keep it here because if it's coming.
No.
Do you see something now?
Yes. Mm-hmm.
Okay.
Perfectly.
Because I don't for some reason see it in my screen. Oh, I had to click somewhere. Now I see it also myself. So it's 1:30. Shall we wait still for Ronald?
Yeah, it's a bit weird because not only Ronald is not here and we do not have any audience. So maybe there is some delay. I will wait for 1 minute or so and then we can, I think, to avoid further delay.
Run the show, but of course it would be nice to have some audience as well.
Yeah. Aha. Some people.
Let in only now.
Yes, they're jumping in. So just a little bit of housekeeping while we wait for Ronald. You probably noticed I started to record the session, so I imagine that this will be available, will be made available afterwards for those who cannot attend right now. All the speakers should remember to select the full screen mode before presenting so that you can see at the maximum size your slides. I am muting all the speakers and the chat should be used to ask questions, you can simply type the questions there, and I'll do my best to cope with all of them. Following the European standards, I will start, and yes, me too, Bruno. I'll start and welcome our final slate of presenters. We have Pekka Huovila from Finland, Kim Tran speaking from Germany, Yannicka Decote from Belgium, and Olivia, Zara, and myself from Brazil. So this is a quite international session that I hope you enjoy. So without further delay, I would invite our first speaker, Pekka Huovila. Please, Pekka, each of you have 10 minutes to deliver your presentation. Please try to be on time. Pekka, the floor is yours.
Thanks a lot, Vanessa, for the introduction, and I'm very happy to be here. I'm Pekka Huovila, as said, and I have been coordinating this One Planet Sustainable Buildings and Construction Program for the past 6 years for the Ministry of the Environment that is leading this effort. And the co-author of this paper is Professor Usha Iranika from RMIT University, Melbourne. And because of the time challenges, he's not able to join discussion. But just to say that this program will be still running for 2 more years until 2022. We have the mandate to implement the Sustainable Development Goal 12, Sustainable Consumption and Production, in the United Nations 2030 Agenda. And the topic today is to discuss how circularity can be assessed in the built environment. And we have chosen as a reference framework precisely this UN 2030 Agenda. There are 17 SDGs, 169 targets, and 231 indicators. And we have been trying to find out if those indicators that should be accessible in public databases could be used in assessing the state, monitoring the trends, and setting the objectives. Now I try to move to the second slide, if that works. We recently launched in the World Sustainable Built Environment Conference Beyond 2020 7 regional reports on state of play for circular built environments from Africa, Asia, Europe, Latin America, Middle East, North America, and Oceania. And we have drawn global recommendations of how this circularity could be implemented and brought into practice in different regions, countries, and possibly even at the project level. We are also conducting a global survey on how circularity is present in the 2030 Agenda. It's not mentioned there anywhere, but however, many SDGs targets and their related indicators are addressing to that. So far, we have received a bit over 100 responses. We are still continuing the work. Almost half of the responses have been coming from Europe, and we tried to get more response from the global south, where we have mainly been conducting our project activities. We look at the survey, what it says about the goals. So SDG 12, that's logical. We have the mandate for that. It's written in the agenda, and also 11 cities. But then which are the other targets that or goals that relate with circularity? So there are some aspects related with climate change, also in the industry and employment, 9 and 8, then 6, 7, water, energy, health, 3, 17 partnerships, biodiversity mainly related, 15, and SDG 4. So that's the framework that we are working. We're looking at how circularity relates with these targets globally, and then what it could mean in different regions. In the survey on indicators at the indicator level, as you know, some of the indicators relate to different goals. Like as an example, this 12.2.1 is the same indicator on measuring material footprint as 8.4.1. And as you see those green columns there, in the survey that we conducted, these 4 indicators received the highest support. So material footprint, recycling rate, and the use of local materials. This 11C1 is still now a bit under consideration, because when the countries report on achieving the targets there, they have found that maybe even a better indicator could be found for that. And this is the area where we mainly work on. But then the issue is, of course, how does it reflect in different continents, different regions with very different priorities and environments. In addition to those 4 core indicators, we have selected 10 secondary indicators. 2 of them relate with water, wastewater and water use efficiency. 2 of them relate with energy, on clean fuels, renewable energy. Then on 9 industry, we have the CO2 emissions. 11 that is about like slum upgrading, also solid waste treatment. And then on 12 consumption and production, we have the procurement policies and renewable energy again. And out of the climate 13, it's about the national determined contributions, different longer-term strategies, national adaptation plans. So this is the framework that we have been working on. And what we have been doing is that we want to get more survey results from outside Europe to have a bit more balanced. We have organized already regional workshops, like one focusing on Africa, one on Latin America, one on Asia, and we intend to continue that task because there are different priorities clearly found out. Like in Latin America, it's much more about the waste management. In Asia, there are quite many innovative solutions already implementing circularity, even though in our regional workshop it has been very India focused. It's not really covering the continent. In Africa, it was interesting to observe that they feel that it's the most recently or late industry or urbanized continent, which means, and also there's still a lot of indigenous traditional solutions that could be applied. There are still skills that are existing, and actually then some kind of a hybrid models might function in that continent, taking from what has been traditionally already used and what could be then not replaced by some modern solutions, but maybe supported by some other things. And the next steps is also or includes discussion with governments. We have so far implemented project in our program in countries like Colombia, Panama, Costa Rica, Burkina Faso, Kenya, Egypt, India, Nepal, etc., and Global South. And now we have chosen, selected 2 partner countries. One is Burkina Faso again, and the other one is Sri Lanka. And in those countries, we intend to understand better or to find out better which are the local priorities and how to go about with implementing. Could the governments take that as their like guiding principles? Among those, could they be used in public procurement, and how the whole supply chain could be involved? And then the implementation, whether we are able to stay at the regional level or country level, or could it even be brought to the project level? So I think I stop here, and I'm happy if there's any questions that I could already answer, because I think I spared 1 or 2 minutes in this presentation for questions. I try to read, if I have the time, I can try to read from the chat box some of the questions. I think you are muted, Vanessa, but I understood that it's okay. So there's a question of this does not economy model of ROFO that has been discussed a lot, because the linkage between the economic growth and sustainability has been questioned a lot. And there are, of course, 2 classes there. One is saying that if we get economic growth, then we can invest in sustainability. And the other view is that we can sustain focus on services and quality of life instead of producing more products. And of course, the population is still increasing, etc. So that is discussed, but I don't think it has solved yet our challenges. But that's a very relevant question. Yes, another question. Thanks, Valdo, for that. If I still may answer this one right now. We are not at that level yet. We are more at the regional level, but that's what we intend to do now. Then we hopefully can discuss more closely with the governments, look at how that can really be brought to different scales. We are mainly working at the building scale, as you may know or remember, or let's say groups of buildings, neighborhoods. We are not dealing with infrastructure that much, but that's a scale. But the other thing that I did not tell much about is the materials. So we are also working a part of this, like a circularity framework. We are working on responsibly sourced materials and looking at how we can get reliable data from the local materials that would not be excluded from the procurement processes. And that's the other topic. And these two approaches meet. So we are working on circularity top down and materials bottom up. And hopefully we will find the right scale where they can truly meet. Thanks a lot for the good question.
Thank you, Pekka. Now I see that Ronald has joined us. Ronald. He's getting in and on, so maybe it's not functioning. So I will proceed with the moderation. I'm still waiting for my colleague, Ronald Rovers, to join us. He might have technical problems so far. Yeah, but there's no mic on, I think.
Okay. Should I start to share my screen?
Yes, you can proceed, Kim. Kim is our speaker from Germany. She's talking about legal instruments for the design of sustainable buildings. The floor is yours, Kim.
Thanks. So I hope it's working now. Can you see the presentation?
No, it's
Not
black,
yet.
Kim.
It's black.
Mannheim at night.
Exactly.
So
It's getting better.
Hope it's working the second time then. Okay, give it another try.
Yes, please.
All right. So, still not working.
Yes, now we can see it.
Full screen as well?
Now it's black.
It's inconvenient. Otherwise, I might do it like this.
Mm-hmm. Have you remembered to click on the full mode?
Yes, that's what I'm like. When I'm going on full mode, apparently it's turning black.
Okay.
Right?
Mm-hmm.
Okay, so let's just stay on this mode. Okay. So the paper I'm going to present gives an insight on the current legal instruments for the design of sustainable building in Germany. And as we all know, and we heard it today already, the building sector is under high pressure. In the background of urban densification, we are dealing with missing affordable housing, and at the same time, we have the questions of planetary boundaries. And that's a sensitive situation in which we need to find a balance between this need and the urgent necessity to implement strategies in the building sector in order to reduce climate change effects. So the paper, that should be the next slide, right? Okay, so we took a look on current legal instruments, asking us the question whether they are enabler or obstacle for the planning of sustainable buildings. For this, we revised the current legislation in Germany, which can be seen in this graph that we made, where you have the relevant regulations in solid lines and the guidelines in dotted lines, and guidelines are more like recommendations. The gray color deals with general building regulations and guidelines here and on the top, whilst the black ones mark the relevant ones for circularity in the built environment. Then, and that's what I'm going to present in the following, we took a case study with the help of the case study, we discussed whether circular construction is possible and easily feasible with current legal instruments, because that's what we want to do in order to reach the SDGs. And for this, we especially focused on the use of timber as well as recycled and reused materials. So that's the case study we chose. It is a design proposal in an urban context. In this case, it's Cologne. And to just describe it very briefly, it is a 6-storied building made from a timber construction, which is supposed to combine biotic materials together with computer-aided manufacturing technology. And the chosen design principles here were minimum use of land. So as you can see, it's a very long and narrow plot, environmental material selection, as well as on the right, the construction for this assembly. We have a total floor area of 2,400 square meters and a common rooftop garden. And the use of the building is very typical for urban areas where we have a commercial use on the ground floor and living spaces on the upper floors. So how can this be considered within the legislation in Germany? We have 3 main sets of public building law that applies, which are marked in red. The Federal Land Utilization Ordinance, the Bau-NVO, the Federal Building Code, the Bau-GB, and the Model Code, the MBO. The admissibility nationwide is regulated by these 2, whilst the main part of decisions lays in the authorities of the federal states and their specific building codes, which is the BAU-O or LBO. And these are then based on the non-obligatory MBO. And apart from this, we have further guidelines and certification systems for sustainable building, which most of all are not legally binding though. So based on this MBO and therefore also the building code of the federal states, the planned buildings are divided into 5 building classes, which are specified by the height and the area of the building. And according to each class, there's a set of requirements for stability and also for fire protection. And it's quite easy to remember. The higher the building class, the higher are the requirements as well. So if you look back to our case study, the following occurs. We have a height of 17 meters, so that the building falls into the highest building class, which is building class 5. The requirements for fire protection from class 5 on prescribes non-combustible insulating materials with a melting point of more than 1,000 degrees. So that in this case, if we would like to consider cellulose fiber as an insulation material, it will fall out of this range, even though it could meet fire protections even better in some cases. And also mineral insulating materials have a much lower potential in circular economy. And according to these guidelines, it is also not permitted to have visible timber components, and load-bearing components must also be cladded with a fire-resistant material. And the cladding of timber is called encapsulation, and it is supposed to ensure a higher fire resistance which is comparable to mineral materials. And as you can see in these pictures here, the design proposal that we made does not really fit into these requirements. However, in these cases in Germany, it is possible to hand in special permissions also based on discussions with the firefighters, because after all, in general, you have to consider, even if wood is a combustible material itself, it always needs to be considered within the whole building component and the structure in order to draw conclusions on the fire resistance. And also using sprinklers would help, but actually they're not very well used in Germany. So far, multi-story timber buildings up to building class 4, so with a height of no more than 30 meters, are possible in Germany. In building class 5, however, it has been difficult to carry them out without any special permission. So yeah, that's a bit sad because they are already proven international examples or examples that prove that it's feasible. And if we go over to the topic of building with recycled materials, we must consider the German waste and construction law. Here we have the Waste Management Act, which is based on the EU waste framework as a binding federal law. However, it does not set any requirements for the quality or the quantity of waste, nor does it set any specifications for the manufacturing of new constructions regarding their recyclability. Further regulations, just as the further regulations that we have in Germany then, just like with the timber construction, they then again lie in the responsibility of the federal states. And here we have other laws that, for example, require waste to be kept separately, but also here we have exceptions which are possible when things are just not economically feasible or technically possible. And then since 2006, the federal government has been trying to implement the Mantelverordnung, that's a national framework for groundwater, for building material substitution, for landfill and soil protection in order to uniformly regulate and tighten the recycling of building materials, as well as the use of mineral materials. But just like other attempts, like the Communication 20 here, for example, these regulations and guidelines are orientated towards civil engineering and not specifically to the building construction. 2017 then, we have, or since 2017, we have a new building, like a new guideline, which is the Substitute Building Material Ordinance. And this is finally an ordinance that is including the definition of scenarios of the end of waste materials. But still, there's still a long way to go, because so far, if you want to use recycled materials within your building construction, you always need to have individual case approvals, so that all materials must meet the requirements of the DIN or EN norms, just as new building products without any exceptions. And this comes with the consequence of time and labor expensive tests, which then, of course, offer very little economic incentives. So in conclusion, what do we have? In general, the German regulation allows building to be built in wood with a recyclable construction method, so in general, and it is up to the planner to ensure that the required encapsulations can be removed non-destructively and is built without any composite materials, for example. And almost all the construction projects that have been carried out to date in Germany have been applying deviations regarding the encapsulation class or the use of combustible insulating materials. So that I would say, yes, we urgently need an updating in the planning instruments so that ecological buildings do not require any special permits anymore. We need an adjustment of the actual building codes, making it easier to, for example, building multi-story timber buildings in building class 5 in order to serve the demand of affordable housing in urban areas while meeting planetary boundaries. And also reusing materials so far has been difficult to carry out in Germany because, well, you always need this individual case approvals. And here it is important to lower legislative and administrative obstacles. There should be a relaxation of standards, an acceleration and a standardization in test procedures, as well as more information on used products and the end-of-life scenarios. And what, all in all, I could say that we need to somehow lower or make it more flexible or make the guidelines more flexible in order to not cause too much planning effort. And that's it so far. Thanks.
Thank you very much, Kim. Right on time. Right on time. I think if anyone in the audience has a burning question, we could take one or so. And it seems that definitely Ronald is having problem to access the conference website and the room. So if there are questions from the audience, there's the time to try to answer one of them. Otherwise, in the meantime, I would say that your presentation made me feel relieved, because if I think of the situation in Brazil, I always thought that Germany would be a holy grail to pursue. So it's kind of relieving to hear that's not that way that we imagine from far away.
Oh, really? I would be interesting to know why.
So I don't see any questions. We have time for them at the end of the session. So I will proceed, Kim, and we can come back to questions afterwards. I would suggest that we invert the order of the following two presentations so that Olivia can present before me, because she's kind of showing the part one of the same research, and then I can complete in the sequence. Oh, there is a question in the meantime. Is it feasible to let the government relax the laws, do you think? Kim?
I think yes. I think it mainly relies on the responsibility of the government, because so far, if we look at the side of the the industries, for example, as long as there are no economic incentives, for example, or if things are not set by law or by guidelines, there's no motivation or little motivation for a lot of people to move towards a more sustainable way of building. Yeah.
Okay, thank you. We can continue with the discussion afterwards. Thank you, Kim. Olivia is already prepared. I see. Yes. So the next presenter is Olivia Zara from the University of Campinas. Olivia, please go ahead. The floor is yours. You have 10 minutes.
Okay. Good afternoon, everybody. My name is Olivia Zara. I'm from the University of Campinas and Londrina State University in Brazil, and I will be presenting our paper called Balancing Data Requirement and Modeling Quality in Neighborhood Life Cycle Assessments. Since 2008, over 50% of the world's population has been living in urbanized areas. And as of 2018, this value had already increased to 55%. At this rate, by 2050, it is expected that urbanization reaches 86% in more developed areas and 65% in less developed areas of the world, which means that our cities that today only occupy 2% of the world's surface, but have already a critical impact on the environment, will have to grow immensely to accommodate the incoming population. Considering that social and economic development depends on the sustainable management of the planet's natural resources, and that production and operation of the built environment involves 36% of the global final energy use and 39% of energy-related CO2 emissions, assessing the existing built environment impact on nature, detecting hotspots, and developing strategies to support decision-making on sustainable urban planning, take a critical stride not only towards protecting the planet from degradation, but also towards sustainable development goals. However, cities are complex, long-lasting systems, and when attempting to handle urban intricacies, a complexity compromise is to subdivide the urban area into smaller cells, such as neighborhoods. From a variety of existing methods suitable for environmental assessment of urban areas, life cycle assessment stands out due to its ability to avoid burden shifting across life cycle stages, environmental impacts, and territories, and its ability to provide urban decision makers with comprehensible information on environmental sustainability. Nevertheless, due to its comprehensiveness, detailed scope, and multi-criteria assessment potential, life cycle assessment is a data-intensive approach, and given the neighborhood scale, data challenges are even more intensified. Moreover, as the reliability of life cycle assessment outcomes depends on the quality of the original background data, data quality management should be an integrated part of the process. Thus, finding balance between required and feasible information collection and determining the best way to handle data quality and uncertainty should be a priority when pursuing reliable results. Therefore, this study explored how data collection and modeling methods influence the data requirement modeling quality balance in neighborhood life cycle assessment. It explored top-down and bottom-up approaches to generate information input for life cycle assessment at the neighborhood scale with the intent of identifying strategies to improve modeling while balancing data collection needs. It represents the first of a three-phase research project aimed at developing a methodological framework for performing life cycle assessment at the neighborhood scale. To do so, 2 life cycle assessments were performed in a single urban block of the University of Campinas campus, which contained 15 buildings and the surrounding infrastructure, using top-down and bottom-up data aggregation approaches. The method followed 4 main steps. First, general ground rules were established for each approach to avoid methodological bias. Second, the life cycle inventory for each approach was developed following these preset ground rules. Third, both life cycle assessments were performed following identical steps and methodological choices. And finally, results from both approaches were compared. As a general ground rule for the top-down approach, mainly national, regional, and local data based on one specific archetype that best represented all campuses' building could be used. This archetype was modeled using a BIM tool, and its features were then extrapolated to all of the buildings in the studied urban block. For the bottom-up approach, on the other hand, we got the design documentation of each of the 15 buildings and surrounding environment and modeled it using a BIM tool. Then we were able to automatically extract a more detailed bill of materials and gross floor area, enabling a more refined and realistic life cycle inventory analysis. Both life cycle assessments were performed following identical steps in terms of system boundary and methodological choices. A 50 years reference study period was used. The functional unit considered was square meter. The impact assessment methods were cumulative energy demand and CML baseline, and 13 impact categories were considered. In terms of results, we were able to identify significant contribution discrepancies between both approaches. For example, when comparing the contribution per life cycle phase, we can see that the replacement stage is considerably underestimated in the top-down approach, which is dominated by the operational energy contribution. This can also be seen when comparing results of the contribution analysis at building elements level. The top-down approach is still dominated by the energy use contribution, while the bottom-up approach highlights the impact of interior partitions and finishing, which should not be neglected, for the impacts are substantial. In terms of construction materials contribution, the main impact contributors in the top-down approach were concrete, reinforcing steel, and asphalt mixture. Yet, galvanized steel and aluminum frame stood out and clearly surpassed concrete and asphalt mixture's contribution when the inventory was detailed by the bottom-up approach. Finally, when contrasting absolute results, the significant differences between bottom-up and top-down approaches confirmed that only one archetype was not sufficient to represent all of the buildings in the studied urban block, and that a more detailed study to determine a minimum number of different archetypes is needed. In conclusion, the top-down approach underestimated overall impacts. Influence of the interior finish and wall partition is not captured by the top-down approach, but should not be neglected, for the impact are substantial. An evaluative hybrid approach will be pursued to gradually improve both background archetypes and foreground bottom-up objects, comprising, among others, of a context analysis of the neighborhood, archetype definition complementation, a bottom-up approach lifecycle assessment of these chosen archetypes, establishment of a data quality scale into levels to identify how each data should be handled in terms of uncertainty and sensitivity analysis, and cutoff rules that can limit data requirement and improve modeling. Finally, in terms of future research, cluster sampling techniques will also be applied. They were actually already, to derive a minimum range of archetypes to adequately describe the studied area, assisting on a more representative hybrid approach. And this is what Professor Vanessa will be presenting in the next session. Thank you, everybody.
Thank you, Olivia. I will not give time for questions now because I'm just going to speak right after you. So let's see if I manage to share my screen, and I'll have to time me up also. It seems that Ronald has not managed to do so. So let me stop it here. Okay. All right. So this is actually kind of a continuity of the presentation that Olivia has just delivered regarding the subdivision of our data set into different archetypes and clusters. So I am Vanessa Gomes from the University of Campinas in Brazil, and I am one of the authors of this paper. Given all the information that Olivia has just provided to you, it's perhaps good to reinforce why this kind of approach is useful. It's mostly, for example, for policy support to bridge the scale gap between the meso and macro scales that policies typically focus on, while the interventions actually happen at the micro scale, at the building scale. It's also possible to establish and test scenarios, or as in our case, to set performance goals for new designs. To do so, we need to first define baselines and benchmarks based on existing instances. It all started in our case when the university acquired a neighboring area that was expropriated by the state to enlarge the existing campus by about 60% or so, and integrated the whole thing to the state technology park systems that was created 10 years before that in 2003. What you see in red is the area reserved for the International Hub for Sustainable Development, which is encompassing not only the Unicamp area, but also 2 other universities, several research centers, technology companies, and should be developed according with the best practices regarding sustainable urban and building construction. But how do we define the baseline in practice? It might sound funny for some of you, as several places or some places have developed a set of representative or average buildings, but most, if not many situations, most of them lack basic characterization of the built areas and need a starting point. The procedure used in the first case to define the set of average buildings is not always well detailed in the literature. Hence, we had a twofold goal to not only explore different data aggregation techniques, but also to make decision-making very explicit to help others that would follow us. For those who are not familiar, clustering is actually a pattern recognition technique which divides the entire data set into meaningful groups called clusters, based on the patterns found, so that the data items within each group are similar, but are dissimilar across different groups. Probably the most well-known and used partition method is the k-means, which partitions a set of n points into a k number of clusters, such as in such a way that the distance between each point and the centroid, that is the average of all points in that cluster, is minimized. Just to illustrate and make it easier to visualize, we start by assuming a certain number of clusters, and then to initialize the cluster centering positioning. Then the R code starts running by the first line of the data table and calculate the distance between the data point and the closest, the nearby cluster centers. And so it goes until all points in the data set are assigned to one of the clusters. And this, at the end of this iteration period, we can notice that probably the original cluster centers were updated to best reflect the actual data set in each cluster. At this point, the algorithm terminates or go back to the previous step until we reach convergence, and the clusters are stable and no data point is jumping from one cluster to the other. The tricky part in using k-means is that each data item must be represented with numerical attributes. A centroid is then mathematically calculated through the average of the points present in that cluster. But the thing is, when we want to have an actual point in the data set as the representative, or if it is the case in which the data set mixes quantitative and qualitative attributes, it's better to use the so-called PAM algorithms, which is a partitioning around medoids technique. And Clara, just for clarification, Clara is a variation of this partition around medoids that's often used for large samples. Another possibility, or a complementary possibility, is to use hierarchical clustering, in which we don't need to predefine a number of clusters, and we can proceed either by agglomeration, starting with one observation in a cluster of its own, and successively aggregating and merging to form one big cluster in the end. Or we can go the other way around by division. The height in the cluster dendrogram indicates the distance between observations and or clusters. The problem that we had in hand was to group over 300 buildings into the minimum number of clusters possible, so that we would have the minimum number of archetypes needed to describe the sample and to carry out the bottom-up LCAs in the end. In the data table preparation, we excluded all buildings with less than 500 square meters. We kept the variables limited to those that would be observable from image analysis. We cleaned and normalize the data table before running the R code and the language routines to avoid errors, crashes, and distortions. And basically what would be included in this data table were the architecture and constructive features like the area, number of floors, and the plan shape, and also the materiality description of the structural frame and envelope as they are relevant for the embodied impact assessment. In the clustering stage, we use the RStudio statistical software, which counts on specific packages for clustering to test the methods that I just explained. And we assessed clustering quality using two metrics. First, the Gower index, which calculated the partial similarity of each variable before normalizing the data so that we would eliminate differences across the different magnitudes. The other metric was the silhouette value, which is a measure of how similar an object is to its own cluster when compared to the neighboring clusters. The higher the value, the best it is the combination of the data point within the cluster. For practical reasons, we decided to pick the best clustering arrangement under 10 clusters so that Olivia would survive the lifecycle assessment stage. As a result, what we notice is that in general, regardless of the clustering techniques, the data set was always best divided into a large number of clusters, above 30 clusters or so. In this case, we can see that the highest silhouette value would refer to the clustering using 38 clusters, but we could have a similar value for only 4 clusters. Same thing happened for the hierarchical clustering. We would have as an optimum number 68 clusters, but we could also have a very similar silhouette value for using only 4. For thinking they would be, this would be a very low number of clusters, we decided to go instead for the K-medoids clustering, which suggested 9 clusters instead. But the clusters had high homogeneity and high quality representatives. Computationally, this is a more expensive method, and the cost would increase with the number of clusters, but still, restraining the maximum number of clusters to keep the subsequent LCA work manageable may impose some quality loss, but is a necessary evil. And as we can see here, perhaps a better solution or a compromise would be around 17 clusters, but we stick to the 9 clusters we had up front. As I mentioned, the best division is when we can count on a high number of clusters, but this is hampered by the time and cost availability, the resources availability. And perhaps the most important piece of advice we could extract from this work is to try to explore as few variables as possible, because as we use the high number of factors of variables to depict the neighborhood, in the end, we had too many possible data combinations that made the pretreatment and assessment very difficult. Thank you very much for bearing with me, and I'll just pause here and stop sharing. Let's see. I can go back. Okay, so now we still have a few seconds if anyone has questions for both Olivia and I right now. Otherwise, we can wait a little bit and proceed with the next presenter. Let's see if something pops up in the chat. No. So I would then invite the next presenter. It's Yannicka de Korte from Belgium. So if you could please upload or share your screen.
It's not working, the screen share, so.
Take it easy. Take it easy. You can try it again.
Try to refresh my browser. Okay.
Yes. Please introduce yourself, Janneke.
Okay, so hello everyone, my name is Janneke de Korte and I am a PhD student at Ghent University. The transition of our building stock towards climate neutrality has become a well-known fact. We will, amongst other things, need to renovate our building stock And in Flanders, already 95,000 dwellings should be energetically upgraded each year, and this only represents a very small part of the world. The way of renovating today involves time-consuming, manual, on-site techniques, making it inadequate to address these large numbers. And for this reason, the industry is searching for faster, more efficient methods, such as prefabricated renovation solutions. Both research and practice has shown that prefabrication can offer many benefits in terms of time, quality, safety, waste, nuisances, and so on, but the environmental impact is rather unknown. Is prefabrication also an ecologically worthy alternative to on-site renovation? To answer this question, we elaborated 3 reference systems: a prefabricated sandwich panel, a timber frame panel, and an on-site attics panel. The different constituting materials are displayed on the slide. Only the finishing is assumed to be equal and the rest of the composition is different. Each system also has an identical functional unit, being 1 square meter facade renovation panel with a U value of 0.23 watt per square meter Kelvin. To quantify the environmental impact of the reference systems, we have used LCA, or lifecycle assessment. The research concerned a cradle-to-grave approach over 2 life cycles of 60 years, including all material-related stages: the production, construction, replacement, and end-of-life stage. The operational energy use is assumed to be equal, so this is not considered in the study. We used the software CIMA Pro, and environmental data were obtained from the Swiss EcoInvent database. And furthermore, the recipe endpoint method was applied to translate all inventory data into environmental impacts. The final results were converted into a single score expressed in points. To indicate the differences between on-site and prefabricated reference systems, each life cycle stage got a separate focus in the paper, but for this presentation, I will first zoom in on the results regarding the production stage. Then I will talk a little bit about the end-of-life scenarios we assumed, and in the end, I will come to the environmental impact over the considered 2 life cycles of 60 years. So on this slide, you can see the results of the production stage. The left color bar of each reference system indicates the impact to produce each constituting building material. So you can see that the on-site attics has the lowest environmental impact due to its simple composition and low weight. The prefab system consists of multiple additional layers such as adhesives, glass fiber, polyester, and wood, resulting in a higher impact. We can also see that there is a significant contribution of the mounting mechanisms. The attic system is mounted via an adhesive mortar and high-density polyethylene plugs, and a double rail anchorage system in galvanized steel is used for both the prefabricated panels. The impact of the galvanized steel rails is almost 3 times higher than the adhesive mortar used to mount the attic system. And for this reason, we also investigated 3 alternative mounting mechanisms for the prefabricated systems. This is shown by the other bars in gray. So the dark gray part represents respectively galvanized steel hooks, PVC rails, and adhesive mortar. So in case of the steel hooks, we limited the required amount of steel. In case of the PVC rails, we changed the material in which the rails were produced. And in case of the adhesive system, we assumed the same mechanism as we used for the attic system, so for the on-site system. From the results, we can see that the alternatives score significantly better than the original mounting mechanism. The highest reduction is noticed from the galvanized steel hooks and also the PVC rails. With these systems, the panels also remain easily demountable, which is a positive aspect in terms of circularity. For the further research, we continued with the steel hooks. So for the end of life stage, we elaborated different scenarios per reference system. It was not the intention to perform a detailed end of life scenario analysis, but to provide some first insight in how to address the benefits of circularity from a practical viewpoint based on a more limited number of scenarios. So we consider landfill, recycling, and reuse. And in case of attics, we assumed that the system was fully disposed and sent to landfill, since disassembling of the separate materials is rather hard because all layers are glued. This is also the case for the sandwich panel, but there we assumed that the steel hooks could be reused in the second life cycle we assumed. In case of the timber frame panel, only the plaster layer and the fiberboard will be sent to landfill, and all other building materials are assumed to be high quality recycled because of the dry connections. The steel hooks are again considered to be reused in case of the timber frame panel. And this brings me to the conclusions of the environmental impact over time. On the y-axis, you can see the recipe single score. And on the x-axis, you can see the timeline going from 0 till year 60, representing the first life cycle, and then from year 60 to year 120 representing the second life cycle. The impact over time is shown in orange for attics, yellow for the sandwich panel, and blue for the timber frame panel. In year 0, you can see the impact of producing and transporting the 3 reference systems. As highlighted before, the attic system scored best due to its simple composition and its lightweight. Each 20 years, you can see an identical increase reflecting the replacement stage for the plaster layer. After 60 years, the end of the first life cycle is reached and the second life cycle starts. On the one hand, this will cause an end-of-life impact, which is the highest for the sandwich panel, followed by attics. And in this case, the timber frame panel has the lowest end-of-life impact due to the high-quality recycling and the reuse. On the other hand, the reference systems also need to be reproduced and transported, leading to a similar impact as in year 0. However, the steel hooks will be reused in the second life cycle, which will lead to a lower production and transport impact of the prefabricated systems in comparison to year 0. The second life cycle then follows a similar pattern as the first life cycle, and after 120 years, we can see that the impact of the prefab systems is still higher than attics. We didn't fully address the circular benefits of the timber frame panel yet. An estimation of the most optimal situation is indicated with the blue dashed line. In this case, only a limited production impact is considered in year 60, since we there assumed that the materials can be recycled for 100% and that we don't need primary raw materials to produce the panels in the second life cycle. So in principle, the reality will lie somewhere in between the dotted and the full line. But in this way, the environmental difference between attics and the timber frame panel has become rather limited. And this brings me back to the main question of this research: is prefabrication an ecologically worthy alternative to on-site renovation? At this moment, I would say no, not yet. Attic scores best at almost all stages because of its simple construction and low weight, except when looking at the end-of-life stage. Then the timber frame system scored best due to the circular benefits of the dry connections. After enumerating the results of all stages, attic still scored best. So an extensive redesign would be a crucial first step to achieve more competitive results. And in addition, we should look for a consensus in how to address the advantages of circular aspect in a more reliable way. So this was my presentation. Thank you for your attention. And if you have any questions, feel free to ask them.
Thank you very much, Janaika. So now we are officially open for questions. Please use the chat bar, the blue bar at your right-hand side. While we receive the first questions, maybe I have some notes that I put down in here. First, starting with Pekka. Well, first I would like to offer, I don't know if you reached Brazil, which countries you reached in Latin America, and maybe we could help you to enlarge the number of respondents regarding your questionnaires. So the first comment is an offer, actually.
Yeah.
And the question, and then you can say it all together. The question would be, which kind of audience do you envision for this kind of indicator system? And do you think of it as the assessment framework, or it could be combined with different frameworks to provide the circularity assessment in the end? How do you envision it?
If I first answer from the Latin American partners, it's mainly Argentina, Mexico that we have been working. They are in like the advisory board, but then we have also strong partners in Colombia, Brazil also, and I can provide you more detailed information, but these are mainly the countries that we operate. And then to your question, who are the target audience, we are starting with the governments and need to engage the whole supply chain. So we are looking at the whole value chain on construction and aspects related with this implementation of further development, customization, localization, that is linked with the capacity building, and that is needed at all levels. So this is the approach we are using.
Mm-hmm. And I think I saw a similar question in the chat earlier on, because from what I could notice, you are using different types of indicators. For example, some of them are just yes or no, like is that policy implemented, or while other indicators are kind of quantifiable. So have you progressed on this analysis, or you still plan to have different essence in the indicators used?
In these regional workshops that we have conducted in different continents, we have tried to go more in detail. And then there are also those generic indicators that are not specifying like the topic related with education or procurement or others. So if you add there this circularity, which is like our approach, then you could develop the indicator based on that. The starting point was that the countries are already reporting using these international databases, and the access should be available. So we are not trying to create some new indicators, but rather derive from the existing set the relevant ones. So that's the approach.
Mm-hmm. Mm-hmm. And using the rationale of the Sustainable Development Goals as the background. Mm-hmm.
That was our choice, and we have found it quite useful. It's also when we are discussing with companies and other actors, looks like it has been taken in many cases also as a framework in their strategies. It's very, very easy to communicate when we pick the ones in SDG 9 or 11 or 12.
Mm-hmm. Excellent, thank you. I see two questions for Janaika. So you can read it by yourself, Janaika, or would you like me to do so? Can you see them?
Yeah, I can see them. I'm sorry for the background noise. Would it be better to focus on improving the non-prefab solution and instead of the prefab solution? I would say no, not really. The note I want to make is that you would really try to improve the prefab solution. We now looked at fixed numbers of reference systems, but prefab really shows that you can handle faster and that there are many benefits. But the problem is now that the impact of the materials we use to do it in a prefabricated way is too high. And so I would recommend to really look at prefab solutions, but to redesign it from the beginning on and really look at the materials, so at the production stage, because we see that the production stage is the highest influencer when you look at the different stages. And besides that, also to look for materials that go on more than 30, 40, 50 years, but really look to materials that have a long lifespan. So we don't need to replace them so fast. For example, with steel, in this study, we assumed the lifespan is 120 years. So you could integrally reuse it and no impact is caused anymore by the steel. Also, although it has like a high initial impact to produce it in the first time. So I wouldn't say we don't need to focus on prefab solutions because it has way more other benefits besides the environmental impact, but we really need to optimize it before we use it. I also see another question about, I think, the elements of the facades or the building components we can expect the most advantages of. I think the facade is important to look at, but also the other parts of the building. For this study, we only looked at the facade. But for example, roof, windows, foundations, and so on also need a certain focus, but it was not within the scope of our paper. But we really need to look at the production impact, I would say. And because the end-of-life impact has a quite small impact, we need to look for how can we reuse it and how can we recycle materials as much as possible to make the production impact lower, to reuse materials. Hope this answered your question.
Okay, thank you, Janneke. I'll just move on to Kim, and then you can think about the questions that popped up in the chat. Okay, in the meantime. So, Kim, I understood that you mentioned that there are no alternative compliance paths in Germany to encourage sustainable building some sustainable building solutions that are not covered by the current regulations. I imagine that there is a lot of good work going on in such an exemplary country like Germany is. So what do you think causes the main gap that it doesn't reach the practitioners? And you face difficulties like you just described it to us.
Can I ask, like, what do you mean with what does not reach the practitioners?
Because it seems that you're facing challenges to implement some of the most advanced sustainable building solutions, like you explained. So I wonder if aren't there perhaps the good work is being put on the right places to reach the practitioners and to cover these gaps between regulations and practice, so that you could effectively implement sustainable solutions into your designs. So where do you think it's the gap, the main problem?
I would say right now there are several gaps that you need to face all at the same time. So, and for this, I think there are several. It's not just the regulations or the law, the policy makers. It's at the same time, it's also the industry who all need to work together. So it's not just like that we need only the energy coming from the government side, but we also need for the practitioners to become more active in this. And that actually we have this in Germany already. So what was going on in Germany right now is that we have the Association of the Architects for Futures, who started a petition because they started to read about it, and they know that once you have a certain amount of signatures for a petition, it needs to be considered within the plenum and the government. So it's not just the government starting to do something, it's we need to inform ourselves as well. The industries, well, they already know that there might be a market in this, but also on this side, we might need new actors that are kind of connectors in between industries, practitioners, policymakers. So I would say there are many, many tiny gaps to fill at the same time.
Okay, I understand that. So thank you very much. Olivia, I don't have questions for you because I know your work, but maybe you want to comment since the time you started to do that research and to the point you've reached now. Do you think which would be the best path to track, or have you chosen the right or the best path to develop your research now that you know a little bit more about how to create the baseline and the benchmarks and the archetypes. What would you suggest to others that would be perhaps in the same situation as you, that need to create a baseline to start to propose environmental goals for urban areas?
I think that the best path would be to choose the type of, not choose, but consider the type of data that you have available when attempting to do a life cycle assessment of an urban area. And with the data that you have, do the best that you can in terms of identifying uncertainties and doing sensitivity analysis, because we now know that when we find more archetypes, or that is, when we have a more representative material to work with an urban area, we have better results. But that's not always the case. Usually, especially in countries that don't have, that are under development, we don't have the access to data as much as we should to have reliable results. So we need to use math to get there. So my advice is to get the best data that you can, and if that's not enough, use math to get the best results that you can.
Okay, thank you very much. And I'll then go back to the, there's some discussion going on there. I'll then go back to Janaika. Just a curiosity, this is not a commercial product, right? You are developing it. And this is not a commercial product yet, right? You're still developing the solution.
Indeed.
And I understood that you said that the situation, that the stage of the life cycle in which that product would kind of have the best performance from all stages you observed would be in the end of life. Is that correct?
Then the prefabricated system from the timber frame was the most optimistic, the best situation, because you could, besides the fiberboard with the plaster layer, that's hard to separate, but from then on you could really disassemble the structure as it is and really recycle, like, for 100% the materials, because they are not degraded, they are not polluted by other materials. So the benefits of recycling and the reuse of the steel hooks in a second life cycle, so that was purely reuse, so no impact was related to that anymore, except from the production. So that is really a focal point in circularity, I think, that we can say how to address the end of life in just a way that everyone does it like that, because now there's no consensus on how to address the end of life stage.
So that would be the fragile point in your assessment.
Yes.
Even though the best solution would be noticed by the end of life, it's also the worst, or let's say fragile, modeling part on your study. Exactly, the end of life. That's where you have to improve it and to add the circularity concerns. Okay. And just by curiosity, why did you decided to use a single score? To communicate better with manufacturers?
It's just easier for people to interpret it. But there are, you don't see like the different indicators, but it's way harder to interpret different indicators than when you just paste a single score on it. But it is really important to look at the different categories when you're analyzing your results. So it's not just one score that you can put on it, but you really need to take backgrounds with you when you do the analysis, and also try to report it.
Okay, thank you. Let's see if we have more questions there. There is one open question by Ronald back there. Environment.
I had one earlier, if you scroll up.
Oh, please, go ahead.
Maybe I can explain it if it was not so clear. So I understand circular buildings can be done in two ways. Firstly, you take like used materials and then you build your building using those. Second one is design for disassembly. And then you can design it so that you can deconstruct and build it again. So these are the two main approaches. And now that what I was looking at your analysis, I understood that you made LCA after 60 years. But what about had it been 20 years or 30 years, the service life, when you need to consider it, would it have been different? And the second question was on this. I understand that there's downcycling, recycling, and reuse, but you are not talking about upcycling. What about, which are the components that you could, let's say, develop that perform even better in the future conditions, not only in the same purpose, but even upcycling? So these were the questions.
Yeah, about upcycling and downcycling, we did something in between. We didn't downcycle, we didn't upcycle. We just said the materials that were produced once were recycled for 100%, and all these materials could be used as secondary materials, and no primary materials would be needed anymore. So it's just, 100% recycling, and it's not upcycling, but also not downcycling. Then the first question was about, I'm sorry, I forgot it.
If you would have found the need to disassemble, deconstruct those solutions in a shorter service life, like after 20 years or 30 years, would the analysis be different than now that you considered 60 years as a service life?
Yeah, the lifespan is really important. So I would say yes, it's something you also always need to add as a sensitivity, because if you include a smaller lifespan, the benefits of end of life could be higher. So then it would be the case. So if you step by step, so for example, the attic system needs to be replaced fully and need to be produced fully every 30 years, the impact the difference between the prefabricated that can be disassembled will be way lower compared to the attic system, because every 30 years you will need to reproduce every material. So the smaller the lifespan, the more the benefits will come to light. So if we're talking about adaptability and so on, so it's changing functions, changing materials, then there is the point that you look to smaller lifespans from 20, 30, maybe 10 years. So then the benefits will be larger.
Okay, thank you all for your presentations, for the good discussion in the chat. I'll now invite you to end the session. If you want to continue the discussion somewhere else, you have all the contacts, you can continue to talk later. And I would like to wrap up the session. And thank you, the audience, and thank to all presenters for participating. Thank you very much. Enjoy the conference.